We've got our nodes and groups working pretty well. However, when we get to the point where we need to save them, we'll need to keep their names in mind. The reason why is actually pretty simple. We'll be saving them as scriptable object assets. That means we cannot have nodes nor groups with the same name in the same scope, as they will be transformed into actual files and folders. Because we are going to divide them into grouped and ungrouped nodes, we'll be having two scopes. A dialog node inside of a group, to which we'll call a grouped node, and a dialog node outside of a group, to which we'll call an ungrouped node. Because each group will end up acting as a folder, nodes inside of the same group cannot have the same name. They can, however, have the same name as nodes of other groups or any node that doesn't belong to a group, simply because they will be within different folders. Nodes outside of a group follow the same logic. They can have the same name as grouped nodes, but cannot have the same name as ungrouped nodes. We'll start by making those ungrouped nodes and make sure they all have different names. We'll also be updating their colors to tell the user that these nodes have the same name, which will later on disable the save button whenever that error happens. To do that, I'll be using the Serializable dictionary script I've talked about in the requirements video, to which I'll leave a link in the description. However, I don't think you need that here as we are not really going to save these lists anywhere, so you are likely able to use normal dictionaries until we need to actually save the data. Because in my version I can use it the same way I use normal dictionaries, I'll just use this one. If you are using Unity 2020, downloading it is all you need to do to be able to create a variable of type Serializable dictionary. But if you are using 2019, I suggest you watching the requirements video and go check what else you need to do to use them. I'll have it placed within an assets folder named Dialog System, and inside of another folder named Utilities. What we are going to do is quite simple. Whenever we add a new node to the graph, we are going to add that node to a dictionary. That dictionary will simply contain all existing nodes in the graph, and it will be used to determine whether a name is repeated or not. Therefore, the structure of the dictionary will be the following: the name of the node as a key, and the list of nodes with that name as a value. Whenever we add a new node, we'll check if there is a key with that node name already, and if there is, we'll simply add that node to its list. If there is not, we then create a new element in that dictionary with its name as a key and a new node list that only contains this node. Then we are going to need a way to tell the user that the graph has repeated node names. For that, we are going to be adding a custom error caller to every node whose name is not unique. And we know a node name is not unique when the count of the nodes list in the dictionary is over 1, meaning there is more than one node with that name. To remove the error is also quite simple. If the node list arrives to the count of 1, then any error should be removed, as there is only one node with that name. And when it arrives to the count of 0, then the element in the dictionary should also be removed, as no nodes with that name exist anymore. As we know, we are going to have the list of the nodes that have the same name. However, I'd also like to have a script that we can use to generate a caller for the nodes that have the same name, so that the chances of different named nodes having the same error caller is low. And this will also make it so that nodes with the same name will have the same error caller. And to do that, I'll be creating a new C# script that will hold the current generated caller and have a method to generate a random caller. So let's go to our dialog system editor folder and create a new folder to which I'll name data. And inside this folder, we'll create yet another one named error. Then, inside the error folder, we'll create a new C# script to which I'll name DSErrorData. Opening it up, feel free to remove the default methods and the mono behavior inheritance as well. I'll make it subnamespace data.error. In here, we'll need three things: a caller variable, a method to generate a caller, and a constructor, which we'll call the color generation method. So let's start by creating an automatic property by typing in public color, and I'll name it color and set it as an automatic property. Then we'll create a method to generate the color, so type in private void and I'll name it generateRandomColor. You can make this method public if you intend to use it somewhere else. Inside this method we'll initialize our variable, but I'll be using color32 instead, as color only accepts values from 0 to 1, and searching around, color32 seems to be slightly faster, which in our case should not really be something to worry about. But most importantly, it accepts values from 0 to 255, which makes it easier in my opinion. We will however need to cast the values into the byte type. So type in color equals new color32, and as parameters to the color32 constructor, we'll be sending random numbers between 0 and 255. Although I found that sending 0 to 255 made the error color look like the default color sometimes, so I'll be giving it other ranges that I found to be okay, but feel free to give any range you'd like. So type in random.range, and for the red value I'll be sending in 65 to 255. For the green we'll be sending in 50 to 175. And for the blue we'll be sending the same. For our alpha we want it to always be fully visible, so we'll send in 255. Remember that random.range max value is exclusive when you send in an integer, so you'll actually need to sum 1 to the last value, so 256 and 176. We now need to cast this integer value to byte, so simply type in byte between parentheses before the random.range method. We are now generating a random color, so all we need to do is to call this method in the constructor. So type in public DSErrorData, and inside call the generateRandomColor method. We now have our error color generating, but there's still a problem. When we create our dictionary, there will be no way for us to tell our nodes in the dictionary list to use this color. What we'll do to fix that is to create yet another script that will hold both the list of the nodes and a variable of type DSErrorData that simply holds a common error color for all the nodes of a specific name. Then we'll make that script to be the value type of the dictionary. So let's go back to Unity and create another C# script in the same folder, to which I'll name DSNodeErrorData. Opening it up, remove the default methods and the monobehavior inheritance. I'll also make its subnamespace data.error. In this script, we'll have a variable for our error data and a list for our nodes. So let's go ahead and create a property for both of them. So public DSErrorData, and I'm going to name it errordata. Then public list of DSNode, and I'll name it nodes. Of course, we need to import the elements namespace to be able to use the DSNode class. The only thing left to do is to initialize both variables, and we'll do that in the constructor. So type in public DSNodeErrorData, and inside type in errordata equals new DSErrorData, which will generate our random color for us. And then nodes equals new list of DSNode to initialize the list. We now have our two error classes, so all that's left to do is to create a dictionary with them in our GraphView script and add our nodes into it. To do that, let's go to our GraphView script and create a new private variable of type Serializable dictionary. And for the key type, I'll send in string, as the key will be the name of the node. As for the value, we'll need to send in our DSNodeErrorData, so let's first import the data.error namespace above. Then we pass in DSNodeErrorData, and I'll name this dictionary Ungrouped Nodes, as it will be for the nodes that are not part of a group. Next, we show the initialized list in our constructor, so let's go there and type in UngroupedNodes equal new, and Visual Studio already gives us the autocomplete option to initialize it. All that's left now is to add the ungrouped nodes to this dictionary. And the way we'll do that is quite simple. Every time we create a node, it is an ungrouped node. That's because we don't have any feature that allows us to create a node inside of a group. So we can safely assume that there will always be ungrouped nodes on creation. So let's go to our createNode method and call a new method we'll create named AddUngroupedNode. We'll be needing the node name and the node itself for the dictionary, so let's pass in the created node to this method as an argument. I'll add this method to a new relation named repeatedElements. And also make it public. I've already explained earlier what we need to do, but in short, if there is no element in the dictionary with the name of this node, then we create a new element. If there is one element in the dictionary with the name of this node, then we update that element. So let's first make our node name a variable, and to do that type in string node name equals to node.dialogName. Then we'll check if the dictionary does not have an element with this key. So type in if UngroupedNodes.contains_key and pass in node name, and make sure you add the not operator at beginning. We will then need to create a variable of type DSNodeErrorData and add our node into its list, so let's do that. Type in DSNodeErrorData and I'll name it NodeErrorData and call its constructor, meaning our caller and list will be initialized. Then we type in NodeErrorData.Nodes and add our node into this list through the add method. We now have our NodeErrorData, so all that's left is to add an element with it as a value to the UngroupedNodes dictionary. Simply type in UngroupedNodes.add and pass in our node name as a key and our NodeErrorData as a value. At the end, we simply type in return so that the code doesn't continue. Under this if statement, we can place the code that we want to call if the node name already exists in the dictionary. And what we want is also quite simple. Add the node to the element NodeErrorData nodes list. So type in ungrouped nodes, and we want it at key of node name, and right now we are accessing this element value, so in here we can simply get .nodeslist and add our node to the list through the add method. We are now adding our ungrouped nodes to the dictionary, so we know which nodes have the same name. But we are not really doing anything with it, so there's no way our user knows they have repeated node names. What we need to do right now is to update their colors. And we do have the error color in our element's NodeErrorData variable, but we don't really have a way to update our node to use that color. We'll actually do that by creating two methods in our node class that updates their main container color, by using the style variable. So let's go to our DSNode class. In here we'll create two methods. One to set its color to the error color and another to set its color back to the default color. So create the first one by typing in public void set error style and pass in a color to which I'll name color as a parameter. Then under that type in public void reset style. We now have our two methods, and we need two things: a way to update the color and a way to know our default color. The first one is quite easy. We simply type in main container.style.backgroundColor and set it to be color. We are now updating our main container background color to be of the color we pass into this method, which will be our NodeErrorData color variable. When we set in the style, we'll do the same, but we'll need to set it to the default background color. Unfortunately, I don't think there is a way to get this default background color through here, as we are setting it up with stylesheets. So I had to go and transform the Xcode in our stylesheet to an RGB code. which ended up being 29, 29, 30. I'll go ahead and create a private variable that will hold the default color, but you could simply just assign it. I'll type in color as a type and name it default background color. In our initialize method, I'll initialize this color to be new color and pass in 29, 29, 30. However, different to the color 32, the color only goes up to 1 and not 255, and our style variables do not accept variables of type color 32, so we'll have to divide all of these numbers by 255 and make them a float. Then, in our resetStyle method, we type in mainContainer.style.backgroundColor and set it to default background color. We now have our methods that allow us to update our node colors. So back to our graph view, the way we'll be updating the colors is quite simple. Whenever we add a new node and there's already an element in the list, that means we are going to have a repeated name. So we can just update a newly created node color. Let's do that by creating a variable of type color, to which I'll call errorColor, and assign it to UngroupedNodes at the key of node name and get the errorData.color variable. We are adding this into a variable as we are going to use it more than once. Then we set our node color through typing in node.setErrorStyle and pass in our errorColor. If we save and go back to Unity, adding a second node shall update its color. However, we have a problem. The first node never updates its color. That's also pretty simple to fix, so let's go back to our method and create a new if statement to which will update the first node color in case the node we've had in is a second node with the same name. So if UngroupedNodes and pass in the key node name .nodes.count == 2, so it's a second node with that name, we can update the first node color. I did this if statement so that we do not always update it at every added node. In here we'll do the same as the above, but only for the first node. So type in UngroupedNodes at nodename.nodes at the position of 0.setErrorStyle and pass in our errorColor variable. You might have noticed we have a bunch of UngroupedNodes at nodenames.nodes in our method. That is alright, but it gets quite repetitive to have to type that in every time. We can do two things here. Either create a variable that holds our DSNodeErrorData so that we don't need to pass in our key every time, or the one I'll do myself, which is just get a reference to the nodes list and use it instead. My way means we still need to get the errorColor value by sending in the key, but I found it to be okay. Feel free to do as you desire. So I'll create a list of type DSNode, to which I'll name UngroupedNodesList, and assign it to UngroupedNodes at nodename.nodes. When that's done, we simply swap our UngroupedNodes references with this new variable. Saving up and going to Unity, we shall now be getting our error colors working nicely whenever we add in a new node. But we have another problem. Our nodes are throwing an error when the names are repeated, but if we update their names, the errors aren't updated. The solution is also very simple. Whenever we update the name of the node, we remove it from its current element in the dictionary and add it again with a new name. So let's start by creating a method that allows us to remove an ungrouped node in our graph view. I'll create it in my repeated element region and place it under the AddUngroupedNode method. So type in public void RemoveUngroupedNode, and we'll need to receive the node we want to remove, so pass in DSNode, to which I'll name node. Inside we'll do the following. We will remove the received node from the ungrouped nodes dictionary and reset its styles. Then, much like when adding, if when we remove the node there is still one left, we need to reset the leftover node styles, as it means there are no other nodes with the same name. If the count gets to 0, we simply need to remove the element from the dictionary, as there are no more nodes left with that name. So let's start by creating a string to which I'll name node name and assign the node.dialog name to it. Then we type in ungroup nodes at the key of node name .nodes.remove and pass in our node. After that's done, we reset its styles by typing in node.resetStyle. All that's left are our counts, so type in if ungroup nodes at node name .nodes.count equals 1. This means there's only one node left, so we'll reset its styles by typing in ungroup nodes at node name .nodes at the index of 0 .resetStyle. Next, we have our count of 0, so if ungroup nodes at node name .nodes.count equals 0, we will remove the element by typing in ungroup nodes.remove and pass in node name. This will remove the dictionary element with the key of node name. You can add a return statement in the if above if you prefer, so that it doesn't check the last if statement. Of course, we can do the same as above and create a reference to the nodes list, so let's create a new variable of type list of DSNode, to which I'll name ungrouped nodes list and assign it to the ungrouped nodes at nodename.nodes. Then simply swap the usages of the dictionary with this variable. We now have a way to remove our ungrouped nodes. So to do that after the name is updated, let's add to our DSNode script and we'll be adding a callback to our dialog name text field. Name it callback and inside we'll be removing the ungrouped node, updating its name and then adding the ungrouped node again. Because we need to call the two GraphView methods, we need a reference to our GraphView. So let's create a private variable above of type DSGraphView to which I'll name GraphView. Don't forget to import the Windows subnamespace to be able to use it. Then pass in our GraphView as a parameter of our initialize method and I'll name it DSGraphView. After that, we simply assign pass-in parameter to our GraphView variable. Of course, don't forget that we have classes that inherit from this class, so let's go to our single and multiple choice node scripts and add in this parameter as well. When that's done, we need to make sure we pass in our GraphView to the node initialize method in our create method, by passing in this. Back to our callback, we now call GraphView.RemoveUngroupedNode and pass in our node through the this keyword. This will remove the node with the old name because in the RemoveUngroupedNode method we are using the dialog name variable, which we haven't yet updated. Then we'll need to update the node dialog name variable. We can do that by typing in dialog name and assigning the callback.newValue variable to it, which is a new text that we've typed in. Then we simply add in the node again through typing in GraphView.AddUngroupedNode and passing in our node, which now has a new name. Saving and going back to Unity, if we insert two nodes and change the name of one of them, everything should work as expected. Of course, we can also delete our nodes through the delete button or the delete contextual menu, and if we do that, our previous error will keep on existing. Thankfully for us again, it's really simple to fix this, as Unity provides us with a callback that allows us to do something when an element is removed from the graph. To do that, let's go back to our GraphView script, and I'll create a new relation to which I'll name callbacks right above our repeated elements region. In here, I'll create a new private method named onElementsDeleted. Inside this method, we'll need to set our callback, and we can do that using the deleteSelection callback variable the graph view provides. With this, we need to pass in a callback, to which it needs two parameters that we won't really need but are mandatory. I'll give them the name they have in their documentation, which are operationName and askUser. Inside the callback, we'll be iterating through the elements that are going to be deleted, and only do something for the elements that are of type DSNode. We will iterate through the selection variable of the graph view, which shows all elements that are selected. And because we are on the deleteSelection callback, it means those selected elements are the ones that are going to be deleted. So type in for each graph element in selection, and inside we'll need to see if the element is of type DSNode. Because we have multiple node types, we need to check if it's from an inherited type as well, and we can easily do that with the is keyword. With this keyword, we do not need to use the is subclass of method, but instead just type in if element is DSNode, and this will automatically check whether it is a DSNode or a class that inherits from DSNode. Then in here, we'll have to remove our node. However, we cannot remove it right away, as we are iterating to the selection list, and if we were to remove it from the graph, the list will be changed and an error will be thrown. So we will create a new list above of type DSNode, which I'll name nodes2delete, and then initialize it. Then in our if statement, we can add our node to this nodes list. We could pass in our element to the add method and cast it there, but C# has something called pattern matching, to which you simply can pass in the name of the variable after our DSNode in the if statement. If you are using Visual Studio and you were to cast the element, it will throw a suggestion telling you to use pattern matching instead. I'll be using it and I'll name the variable node. After we do that, we can continue to the next element. Then, after iterating through all of the selected elements, we'll iterate through our nodes list. So type in for each DSNode node in nodes2delete, and in here we call our RemoveUngroupedNode method and pass in node. Then we need to remember to call in RemoveElement, which is a method from the graph view to remove an element from the graph. We will pass in our node. We need this one because we are overriding what happens when a delete action happens, so Unity doesn't do it for us automatically anymore. We need one last thing, and that's to call this method somewhere, otherwise the callback will never be set. I'll do that in our constructor. Saving and going back to Unity, we should now have everything working. Of course, we still have the removal of the edges left, now that we have replaced the deleteSelection callback, but we'll actually do that later on in the series.